Previously, we have been able to solve quadratic equation using the method of factorization. Today, we want to solve similar equations, but using another method that we call completing the square. Completing the square stems from making a particular quadratic expression perfect square. And when do we know, or when do we say particular quadratic expression is perfect square? For example, let us look at this. If we have x squared plus 10x plus 25, it's a perfect square because given that the coefficient of x squared is 1, if you divide coefficient of x, if you divide it by 2, 10 divided by 2 will give you 5. And if you square that 5, will give you 25. That is, if you divide this coefficient by 2, if you square the result and it gives you the constant, then such an expression is said to be a perfect square. And how do we factorize perfect square when something is, a particular expression is perfect square? How do we factorize it? Look at this, what we do. Since the letter is x, write x, just say what is the half of this coefficient? Plus 5. Okay. So if you expand this back, you will get this expression. And if you factorize this, for example, you want to factorize this, normally the product is 1 times 25, which is 25, and the sum is 10. Two numbers that you multiply to get 25, and when you sum to get 10, it is 5 and 5. So if you factorize this now, you have x squared plus 5x plus 5x plus 25. And x is common here, you have x plus 5. 5 is common on the second one, you have 5 into x plus 5. So at the end of the day, you get x plus 5 times another x plus 5. If p times p gives p squared, then x plus 5 times x plus 5 will give x plus 5 squared. That means this one is a perfect square because it can be factorized into a single expression that has square. So that's why we call it a perfect square. But it's not every quadratic equation that is perfect in nature. Since it is not, if we want to use completing the square to solve a particular quadratic equation that is not perfect, that means what does not make it perfect is what we throw away. For example, suppose you are given this one in the first place. How do we know it's perfect? Half of this, when you square it, must be the constant. But suppose it's not 25 that is there. That means this 25 will not complement this, will not make it perfect. So we'll move it away under equation. So that's what we want to quickly look at. In addition, for example, if you have y minus 6y, and they ask you y squared minus 6y, what must be added to this expression to make it a perfect square? It is half of this, which is minus 3, all squared, which is 9. That means it's 9 that you add to this place. If you factorize this one now, it will give you y minus 3 all squared. Because you pick the letter, then half of the coefficients all squared. So if you expand this, you get this back. So let's move on to business. In our example A here, we have x squared minus 5x minus 10 equals 0. You ask yourself, is this expression perfect? No, because if you divide minus 5 by 2, minus 5 over 2, and you square it, will give you plus 25 over 4. And this one is minus 10, not plus 25 over 4. That means this minus 10 does not make it perfect. We throw it away. X squared minus 5x equals, so move it away, that's 0 plus 10, that is 10. Since you are moving it away, that means you now look for what will make it perfect. What will make it perfect is half of this minus 5 square, which is 25 over 4, as we have rightly seen here. So you now say add half of this coefficient squared, that is 25 over 4 to both sides. So we now have x squared minus 5x plus what makes this perfect equals to 10. So from here, this is perfect now. The whole expression here is perfect now because half of this square is this. So how do we factorize it? Factorize it, the letter, then half of the coefficient, that is minus 5 over 2 squared. If you expand it to give you the whole of these three expressions, these three terms. So equals to, simplify this one. This one is 10 over 1. Just say 4. 1 in 4, 4. 4 times 10, that is 40. Plus 4 in 4, 1. 1 times 25, that is 25. Okay. So from here we have x. The previous equation we solved, sorry, I think what we have here was 14. Although if you want to solve this, we can still go ahead to solve it. But I just want to use the previous equation. Here is 14. So this one is 14. Then 14 here. And here we have it here, 14. We have it where that means this one will be 1 goes in 4 times 14. So if you do 4 times 14, 4 times 14, we should get 56 rather than 40 there. So I just want for us to be able to check that any method we use is correct. So that is why I still try to make use of the previous equation we solved under factorization method. So I don't want it to change. So we have this now. This is x minus 5 over 2 all squared equals to, add 56 and 25. 56 plus 25 gives 81 over 4. So all we need to do now is to solve this equation. To solve this equation, you want to remove this square, you introduce square root on both sides. Square root will cancel this square, and you have x minus 5 over 2 equals to plus or minus square root of 81 over 4. Now, the essence of this plus or minus at the back of root is that if I have square root of 9, this implies that what two numbers multiplies itself to give 9. So it could be 3 times 3 to give 9, or minus 3 times minus 3 to give 9. That means you always have two values for it. So that is why we put plus or minus. So that at the end of the day, your answer will either be plus 3 or minus 3 or square root of 9. So the same thing here, we now have x minus 5 over 2 equals to square root of plus or minus square root of 81 is what? Is 9, and square root of 4 is 2. So let's move this minus 5 over 2 to the right to meet this so that we get the value of x completely or finally. Let me use this place. So we have x equals to, move it here. I want this plus or minus to be in between, although we can move it to the back, no problem. So we have 5 over 2 plus or minus 9 over 2. This means x equals to 5 over 2 plus 9 over 2 or 5/2 minus 9/2. So if you simplify each fraction, 9 plus 5 is 14 divided by 2, that is 7, or this one, since LCM is the same as 2, so 5 minus 9 is -4 divided by 2, that's -2. So we have this answer, 7 or -2 as the answer. We'll quickly go to B and have it solved as well using completing the square method. So for B, to solve B using completing the square method, we have 3x squared minus 10x plus 8 equals to 0. So if you look at this, before you even ask at all that is this one a perfect square, before you divide this one by 2 and now square and check whether it's the constant here to know whether it's perfect square or not, ensure you remove this coefficient. Coefficient of x squared must always be 1 when you are solving using completing the square method. So divide through by 3. 3x squared divided by 3 will give you x squared, minus 10x divided by 3 will give you minus 10 over 3x. 8 divided by 3 will give you 8 over 3. Please write it as fraction, don't convert to decimal so that it doesn't become a cumbersome for you. We have 0 divided by 3. 0 divided by 3 is 0. But 3 divided by 0, 0 over 3. If 0 is numerator, the answer is 0. But if you have 3 over 0, mind you, this is undefined. It's undefined. It's mathematically meaningless somehow. So from here, we now say what is half of this square, whether it will be this. Half of that is minus 10 over 3 times half. So it squares this here one, this here, that is minus 5 over 3 squared, which is 25 over 9. Unfortunately, here we don't have 25 over 9. That means we throw this one to the right. And now introduce that 25 over 9 there, since that is what will make it perfect. We have x squared minus 10 over 3x equals to negative 8 over 3. So we now introduce half of this square, which is 25 over, that's 25 over 9, like we saw the other time, that is. So both sides, x squared minus 10 over 3x plus 25 over 9 equals to negative 3, 8 over 3 plus 25 over 9. So this is perfect now because half of this is minus 5 over 3. When you square it, is plus 25 over 9. So that means this is perfect square now. This left-hand side, the expression of the three, perfect together. So how do we factorize perfect square? Just pick the letter. And what is half of this? Minus 5. Minus 5 over 3. Also, for this one, simplify. The LCM is 9. 9 divided by 3 is 3. 3 times minus 8 is minus 24. Plus 9 goes in 9 one time. 1 times 25 is 25. So from here we have x minus 1 over 3 all squared equals to negative 24 plus 25 is 1 over 9. So we just solve the resultant equation. Take the square root of both sides to remove this square, then it becomes square root a. And we have x minus 1 over 3 equals to plus or minus square root of 1 over 9. So let me create space here. So we have x minus 1 over 3 equals to square root of this is 1 over 3 plus or minus 1 over 3. So we can now take this negative 1/3 to this to the right, so that we have x equals to 1 over 3 plus or minus 1 over 3, which implies x equals to 1 over 3, separate the sign, plus 1 over 3, or x equals to sorry. Here, what we have here is 5 over 3, not 1 over 3. I made a mistake. 5 over 3, 5 over 3, 5 over 3. So 5 over 3 minus 1 over 3. So from here, if you simplify, the SCM is 3. So 5 plus 1 is 6, divided by 3, that is 2. Just normal simplification of fraction. Or this one, 5 minus 1 is 4, divided by 3, that is, or x equals to 4 over 3. So these are the two results that we obtain. And the previous solution, if we check solving this particular equation using the factorization method, this is the answer we'll also get. So do subscribe to this channel and share the video for others to benefit. Thank you. We move on to the formula method that people call almighty formula. Thank you.